So what do I think of this machine after owning it for 3 years? I've had this machine for about 3 years, and it continues to generate a lot of interest. When I bought this machine, I'd never heard of this model, which is the compact mill is the current name. This one is called an office mill, or OM. And there are some things that make it unique. One of them is that it's the smallest of the VMCs, or vertical machining centers, that Haas sells. It's designed so that you can have casters. And if you have the casters, which I don't, then you can raise the screws that hold it down in place, and then wheel it onto a freight elevator, weighs about 1,500 pounds, take it to a different floor, different room, drop the screws to take the weight off the casters, and then you'd be up and running again, which is pretty cool. But I looked into getting the casters for this machine, and it was like $1,500, I think, and that wasn't worth it to me, so I don't have the casters. So let's take a look at some of the things that make this machine unique. First, as I said, is the size. Another thing is the 30,000 RPM spindle with an optional 50,000 RPM spindle. I have the 30,000 RPM spindle. One of the other things that is clear about this machine, if you look at the pricing, is that it's not an entry-level machine. When I bought this machine, and I priced out all of the options that came with it, including the tool holders, etc. The total came to about $90,000, which is well above an entry-level machine like a mini mill. So what makes this machine different is that it's designed for precision. It also runs off of 220 volts, single phase, which is really nice because I could just plug that into the wall of my shop. There are other machines out there like the mini mill that can also run on single phase, or the TM mills, but having single phase is certainly nice because then I didn't need to get a rotary phase converter or some other mechanism to convert from single phase to three phase. Because this is in my house, this is actually a workshop behind the garage, and so in the US we do not have three phase as an option. Inside here is a 5 horsepower motor that drives some belts that in turn drive the spindle. So with a 5 horsepower motor, you would think you can do some serious milling on this machine, especially compared to, for example, Tormach that has just 2 horsepower. That's not the case. Let's take a look at some of the reasons why. Okay, let's start with the spindle. You can see the spindle is quite small and there are no drive dogs. This is a lot smaller than you would see in larger machines like the, even the mini mill is Cat 40, so it's considerably larger. So already this is very different from the other machines. Let me pull this out of the spindle and show you more about the tool holder. So this is an ISO 20 tool holder. You can see it's a pretty small taper, and as I mentioned before, there are no drive dogs. The other thing is that this is an ER16 collet. This is the tool holder they recommend. They do not recommend using anything larger than ER16. These tool holders are made by Techniques and they're not cheap. They're, I think, about $175, something like that. And they're balanced to at least 30,000 RPMs. I'd have to check to see if these are balanced to 50,000, but they do make a version that's balanced to 50,000. These collets also need to be collets that are balanced for at least 30,000 RPM as well. Let's take a look at some of the limitations that are associated with this and described in the manual. Here are the limitations in the manual, and there's some interesting ones, such as roughing operations should use 3/8 diameter or smaller tools. So already that's probably raising questions. Why do you need a 5 horsepower motor if you are limited to 3/8 inch diameter tools? And it gets even better, which is roughing depth of cut should be 20% or less of tool diameter, and roughing width of cut should be 25% or less of tool diameter. So obviously with these limitations, you cannot get very serious material removal rate. So then why do you need a 5 horsepower motor? So what I'll do is I'll start the spindle and go directly to 30,000 RPM. So I'll type in 30,000 and then press clockwise and watch the load. And that's why I need 5 horsepower on this machine. One question is, what is the runout on the tools? So here's the setup I'm using to test the runout. I have a 10th style indicator or a test indicator, and I'm running the spindle at about 50 RPM. The runout, you can see, varies from about nothing to about 6 or 7 tenths, which is pretty good. And one of the things that is possible, which I have confirmed, is that you can use the trick that John Saunders shows on his NYC CNC website of lightly tapping against the shank of the tool, and you can pretty much eliminate the runout doing that. Another thing that sets this machine aside from a lot of other machines, such as the Tormax and the larger Haas machines, is the way the door works. There's a sliding door, which is pretty small, but it's what I use most of the time. And then there is the door that you can open this way, which does provide much better access to the inside of the machine. The inside of the machine is pretty tight. The table has fairly small travel, so it's the travel this way is 12 inches and the travel this way is just 10 inches. Now, one of the things about that, let me move this all the way to the back and bring you in closer and give you an idea of some of the limitations of the size. So again, I have the machine open all the way. What I'm going to do is I'm going to move the table all the way to the back with the jog wheel. And the thing that you may not be able to see very well is that the distance between the back of the vise here and the weight cover is actually really tight. So I've got this vise pretty much as far back as I can to keep it from hitting the weight covers. And in fact, let me zoom you in and give you a better idea of that. So I've got you in here pretty tight, and you can see I can't even put my finger in between this and the weight cover. And if I drop the Z down, you'll notice that it gets tighter as Z comes farther down. Fortunately, I never have to get low enough so that this is an issue, right here, this part right here. So as I say, this is pretty much as far back as I can go with the vise on this machine. Okay, I've got you now so that you're looking down into the machine from the door. And you'll notice that the door here sticks out a little bit more. So when I bring the Y all the way forward, it looks like there is a little bit of clearance here. Yeah, this looks like it's a little bit, about 1.5 inches of clearance. But when I close the door, this clearance drops to less than 1 inch from this end here to the door itself. So there isn't as much clearance as it looks like. The other thing is, if I put my speed handle on with it all the way forward and Y, the speed handle hits this door on both sides. So from that perspective, I'd like to have this farther back, but I can't because of the weight covers on the Z. This vise is a vise that isn't made anymore. It's a 4-inch vise from Shars. And I bought this vise because I had a hard time finding another vise that would fit within the Y constraints of this machine. If I measure from the back of the vise to the front of the hex, I don't know if you can see, let me do it this way. You can see it's about 12 inches. So that means that I need to have a vise that is ideally less than 12 inches. Now, I've been working with this vise since I got the machine. Again, as I say, because I was having a hard time finding a smaller vise. Let me show you one of the disadvantages of this vise. I'm going to set things up so that I can show you the jaw lift on it. All right, I have you in a position where I think you'll be able to see things fairly well. The first thing I'm going to do is I'm going to drop down the Z until we get some movement on this. And the thing you'll notice is that when it moves in this direction, that's when the Z is going down. Moving in this direction also means that's when I'll have lift on the jaws. So let me go ahead and hold this down like so, and then tighten the jaws. And you can see that I'm getting quite a bit of lift. Okay, so put it back in here. Oops, I'm hitting, let me move the X a little bit. Okay, I was hitting the indicator. Okay, so what I want to do is I'm giving this a push down, and then I want to zero that. So I'm going to do that with the Z on the head, because I can move it in 1/10 increments. And you know, there's some movement around with this, but if I push it down quite a bit like so, and then I tighten the jaws, you can see I'm definitely getting at least 0.02 of an inch lift on the jaws, which is not good at all. So I'm going to reposition this and try it with these MMM USA Piranha jaws and see if there's a difference. I don't think there will, but I'll also zoom you in closer to the indicator. So let me loosen this, and you can see it definitely fell about 0.02 of an inch. All right, so I've got it now positioned for the Piranha jaws, and I will set the Z on 0 on this. And if I push down, you know, I'm getting less movement. Oops. There's a little bit of rocking. Let me make sure there's nothing underneath here. And put it back on. Okay, so now it's better. There isn't any rocking. It's pretty close to 0. I'll get even closer to 0. And now what I'm going to do is push down on this and tighten on the jaws. And you can see now I got 4.5 thousandths of lift. So this is really bad. I kind of suspected that I was getting jaw lift. So recently I've been doing some research on other vices that will fit in here. And in another video, I'll give you an idea of what vise I decided to go with. When I first got my machine, I decided I wanted to get a face mill. And so I did some research, and I found this really nice face mill from Glacier. I think that's the name of it, that I bought from a company in England because I couldn't find a company in the US that had these. So very nice size. I believe this is 20 millimeters diameter. And then of course I also needed to get the correct pull stud. I also bought this one right here, which turns out to be quite heavy. I was a little concerned about putting this into the machine, but this was really cheap. I bought it off eBay. And then I noticed something when I tried to use this in the machine, which is it didn't work with the tool changer. And the reason it didn't work with the tool changer, you can see here, the profile of these two is very different. So where the forks need to go in to grab it in the tool holder, it's a very different profile than here. So this is why I finally ended up with this, which is the Tri-Fly from Shrum Solutions. He made a special version from me at the time that had a 3/8 inch diameter shank, I believe it is. I'll have to check. And so I was able to use that in this ER20 tool holder. This is one that I got with the machine. It's the only ER20 tool holder I had, so I decided to use it for this. All of my other tool holders are ER16, which is what Haas recommends anyway. So I'm pretty careful about how to use this. It's a little heavy, not as heavy as this one here. And I'm also careful to take fairly light cuts with it because I don't want too much side load on the spindle when I'm using this. But this does a beautiful job with the surface finish that I get. So right now I have the table, so it's not quite in the 0 position on the left side, left to right, and it is pretty close to the 0 position in the Y. What I want you to do carefully is watch what happens when it moves to 0. So what's going to happen when it zeros is it's going to move this way as well as this way. It's going to get to the end stops, and then it's going to back up ever so slightly. So I want you to take a look and watch for it backing up. So here I'm going to hit the power up restart. And if you look carefully, you could see it come back ever so slightly. The repeatability that I'm getting from that is probably on the order of 1 or 2 10,000ths of an inch, which is going to be as good, if not better, than the Heimer for resetting the position. And so that means that when I power up the machine, if I have something in the vise, I haven't moved it, I can just continue where I left off. This diagram here is something I'm going to use to explain how that works. If you've looked at the way rotary encoders work, they have an A and a B channel that are out of phase by 90 degrees, as you can see here, and that allows you to determine how far it's moved as well as which direction it's moved in. The encoder on the Haas has an additional channel, which is the index channel. And this gives you an idea of how that works. Now, the encoders on the Haas probably have a lot more positions than you see here. But the idea is with the index channel, there's only one position for each rotation of the encoder. So what happens is it's going to reverse until it hits the end stop. Now the end stop is such that it's a little bit away from this index mark. And then it's going to move back in the other direction, such as, to the right, until it hits the index mark. And it moves slowly enough so that I can stop precisely at the index mark. That's how it gets the insane repeatability. Now when I bought the machine, it came with this tool changer, which has room for 20 different tools, so it has 20 positions. And this is not something that I really cared that much about. I came from a machine that had 0 tool changers, and then went to a machine that had a power drawbar that made it easy to change tools, and I thought, okay, that's really all I need. Now that I have the tool changer and use it for jobs like making a mold that took 12 hours, where I could just change between the different tools and I didn't have to be out here all the time, I'm completely sold on having a tool changer. And frankly, I don't want to go back to not having a tool changer. So if you're able to get a machine with a tool changer and you have a choice as to how many tools you can get, go with more than you think you're going to need. You're going to fill it up. I pretty much have this filled up. Now the controller is one of the things that sets a Haas aside from something like a Tormach. The Haas, pretty much any Haas you have is going to have a similar type of controller. There are different versions of this controller. This is known as the pre-NGC, which stands for Next Generation Control. Currently they're shipping NGC. So this is one version before the NGC. This one was introduced in around 2008, 2009, I believe. And so there's another controller or two that appeared before that on older machines. My experience is almost entirely with this version of the controller. I have seen the newer version, but I have just seen photos and videos of the older version. So one of the big differences is with the Haas, you've got lots of dedicated buttons, whereas on a Tormach, you have a touchscreen. Newer generations of Haas do have touchscreens, which again, I don't have. But this is intimidating at first, and then you start to get used to it. So for example, I know memory is where I have the current program. So if, for example, I want to load the startup program, which is used to run up the spindle, I go to list programs. Now I have the different locations where I can have programs, which is memory, USB device, which is what I used to use, the hard drive, which is an option built into this machine, which happens to be where I have the startup program. So I can press page down and then say select program. So once you get used to where all the different buttons are, this is a very fast and efficient interface. By the way, now we're back on the memory page. So if I press start, cycle start at this point, then it will start to run this. And by the way, I can easily switch back to other screens. So for example, hand jog, this will allow me to move by 0.01 inches at a time for each click. And so I can move the X, or I can move the Y back and forth, I can move the Z back and forth, as well as the rotary axis. Now, if I want to go back to memory, it's just a single button push. If I want to do something like set the Z offsets for tools, then I go to the offset page. This is for the tool offsets. Then there's another one for work offsets. So if I go to hand jog, I can see both at the same time. You can see there's a lot about this controller. And again, once you get used to all of the different buttons, you can move quite quickly between the different pages and accomplish a lot. So this is a type of interface where people's first reaction to it is, this is so ancient. Why would you possibly want all these buttons when you can have a touch screen? And as someone who works on software for a living and has used this, I really like the muscle memory because I know that this is where I go for the overrides, this is where I go for the hand jog and the different speeds, so if I want it really fine. And in the X direction, you can see I can do that very quickly. Now granted, you can have the same thing with the touchscreen, and I guess you could argue until you run out of breath which of the two is better. I happen to like this. Now I happen to mention that there are different storage locations in this machine, so go back to list program again. I have these options up here. Not all machines are going to have all of these options. I have these options because I have I think it's called the Ethernet option installed on this machine. And that option gives me USB support. There's a dongle on the right side. It gives me an internal hard disk, which I believe is 40 gigabytes, as well as network share. So if I go to USB, it's going to say there's no device in there because I don't have a USB dongle. If I go to the hard drive, again, I have everything I have in here, but I'm not using most of what's in here. And then if I go to NetShare, which I will in a minute, then there are things that are on the file server, which is from a previous episode. I'm using a Raspberry Pi as a file server because of security concerns. This does have the ability to both write directly to the hard drive from another device as well as have this read from a network device. But those capabilities use something called the SMB version 1, which has known security vulnerabilities, so I don't want to install the software required on my desktop to allow me to write to this because that's a security issue. I want to point your attention to this right here, FNC. All of these features are using something called FNC, which is Haas's version of DNC. And that means it's drip feeding from these different interfaces, USB, hard drive, or network share. Now, this showing up right here says this file is currently selected. So if I press select program again, it will unselect that. Now, where that's important is if I'm in NetShare and I select one of these files here, such as dimension test contour, I'll select that file and then go back to list programs and you can see it's selected. What that means is that I cannot modify this file from my computer on the file server and be able to open that modified version. I have to first unselect this by saying select program before I can modify it. And then once I've modified it on the file server, I can reload it here. That's something that took me a while to figure out. So what I would say is, if you're going to get an older machine, a used machine, it's important you understand what type of I/O that you have. Particularly because quite often these older machines don't have a lot of RAM. If I remember correctly, the RAM on this machine is 1 megabyte of RAM. I'm not really sure. It's not unusual for me to have programs that are much larger than that. So for example, if we go to some of the watch ones and go down here, I'll go to case back. I'll just choose one. Actually, those aren't too bad. Let me go back to this one. Yeah, these are also not that bad. So we're about 1/4 megabyte here, but I've definitely done jobs that have been more than 1 megabyte. So that wouldn't fit in memory. And so being able to use FNC to drip feed from one of these other sources is a good way of getting around to the memory limitations that are on your machine. Now, I've had people tell me that using drip feed, FNC, is a really bad idea. I've been doing it this way the entire time I've had the machine. I've never had any problems. So I would say it's not that risky to use FNC, and it gets around the memory limitations you might have on an older machine. So the thing you want to look for in an older machine is to make sure that you have at least one of these, USB drive, hard drive, or NetShare. Well, if you have a hard drive without the NetShare or USB drive, that's not very useful. So you need something that allows you to get files from the outside onto here, and that's what I would suggest that you look for. Something else you're going to want to check on these used machines is what features come with the machine. So this machine came with a bunch of paperwork, and right at the beginning of the paperwork, it describes the control software version, which it says is 16.06. And then it has high-speed machining, so that's a feature my machine has. It has the A-axis support for the 4th axis, which came with this machine. It has rigid tapping. I've used that quite a bit, and it's certainly really nice. And then it has the hard disk drive, which has the USB, the hard disk, and the network share. So there are many other features that you can get with these machines, such as you can get a wireless probe or the whip system. I don't have that. I'm planning to get it at some point in the future. Those I think sell for about $5,000 or $6,000 at the moment. So, all of these features, when you add them to the price of a new machine, you'll see the price increase. So those are things to think about and factor in when you're getting a machine. Now, for some reason, almost all of the office mills that I've seen for sale have come with 4th axis and things like rigid tapping and the USB option. So a lot of these options seem to be pretty common. Another option that you'll want to look at, and it wasn't that important to me, is whether or not you have a 30,000 or 50,000 RPM spindle. Most of the machines I've seen are 30,000 RPM spindles, but I just saw one today that's a 50,000 RPM spindle. So if you're doing a lot of micro machining, it is nice to be able to go up to 50,000 RPM. But it does mean you'll need to be more careful about the tool holders and the collets that you buy to ensure that they're balanced to 50,000 RPM. Something else that I've noticed in a lot of these machines, the office mills and the compact mills, is they typically don't have a lot of hours on them. These are definitely specialty machines. The impression I get is they're mostly used in the medical or aerospace industry, making small precision parts. That probably goes along with the price tag for a new machine. But the good news about that is it means that the used price is going to be a lot lower compared to other machines. So if you look at a used price on something like a mini mill, for example, it is a lot closer to new price than what you'll find for these office mills and compact mills. Same thing is true with a Tormach. If you look at the used prices for Tormachs, they're not that far away from the original list price. Usually less than a factor of 2 difference. They're a lot closer to the list price. Whereas these I've been seeing for sale for less than half of the new price. So this is a really good deal from that perspective if you can get it. On the other hand, you might be able to get something like a mini mill and definitely a used Tormach for less than I paid for this. In terms of how much I paid for this, if I remember correctly, they were asking about $25,000, $26,000 for this. I made them an offer that was closer to $22,000, which they accepted. And then there was I did have a barbell test done on this. That was another $1,000 or so. And then there was the rigging. I don't remember how much that was, but once everything was delivered and in the shop, it was probably closer to $25,000. So that's something to keep in mind as well. Now the question you probably have is, if I were to do it over again, which route would I go? Would I go with a Tormach? Would I go with something like a mini mill? Or would I go with some other machine? Or would I go with the used OM2 that I have here in my shop? And the answer is emphatically this machine. This machine is the perfect machine for me. That doesn't mean it's going to be the perfect machine for you, because you may have very different needs than I have. Most of my work is making injection molds for desktop machines. So they're fairly small parts, but intricate parts. I consider a 1/16 inch end mill to be a roughing end mill quite often. 1/32 inch mills are finishing end mills, and then if I need to go with detail parts, I'll go smaller to like 15 thousandths of an inch diameter, 10 thousandths of an inch in diameter, or an engraving cutter with a 5 thousandths or 3 thousandths of an inch diameter cutter. So this machine is great for those types of things because of the high-speed spindle and because of the precision aspect. Now, the vise that I have right now is not the best thing for that, and that's something I'm planning to fix, but that's really just the only weak link that I've run into in this system. Except I would like to have the WIPS system, which is their probe and tool measuring device, because that'll give me more accurate tool diameter and therefore should give me more accurate dimensions of the finished parts. I hope you enjoyed this episode. I hope you found it useful. Please subscribe, give me a thumbs up, comment below, and if you're already a subscriber, you can be notified when I have new videos by checking the bell icon next to the subscribe button. Thanks for watching, and I'll see you next time.